Also, we discuss issues surrounding the engineering practices. Today, we will bring you the production of microchips. And also, we have a guest in the studio who is going to be discussing the role of professional bodies in engineering practices. Stay tuned on the program, but first, let's have the production of microchips.
How it's made, microchips. Microchips are everywhere. With the advent of amazing technology comes a greater need for efficient microchips, but they sound minuscule, so if you're wondering about how they are made, we'll discuss that in our video. Welcome back to How It's Made, folks, and today we'll be talking all about microchips. But before we delve into the world of manufacturing, hit that subscribe button if you haven't already. What is a microchip? Microchips are a flat silicon disk that has an integrated circuit embedded on it and even incorporates transistors. There are patterns of tiny switches that are created on the silicon wafer by embedding materials to form a deep and integrated lattice of interconnected shapes. There are elaborate processes that lead to the construction of these interconnected circuits, and we'll discuss all of them in detail. Raw material, silicon. Silicon is the digital gold in the technology industry as it is a widely used semiconductor. The manufacturers often improve the properties of the semiconductor by adding phosphorus or boron. The great news is silicon is made from sand, which is the second most popularly found element after oxygen. Silica sand is a form of silicon dioxide from which silicon wafers are made. The first step for this is by melting the sand into a shape of a large cylinder called an ingot, from where the thin wafers are sliced off. For microchips, good and pure silicon is always a mandatory material, hence only one impurity atom for every 10 million silicon atoms is allowed. Silicon balls are made in the range of different diameters, where the most common sizes are 150, 200 and 300 millimeter wafers. Now, for microchips, the silicon wafers must be really thin. Hence, there is a special sawing technique where these wafers are made. Why is silicon used? Silicon is a semiconductor that is an efficient conductor of electricity provided certain conditions are fulfilled. Every silicon atom has 4 outermost electrons, because of which actual pure monocrystalline silicon is non-conductive at room temperature. To make it conductive, small quantities of specific atoms are to be added as impurities to the wafer. This process is called doping, and most often boron and phosphorus atoms are highly used. The most suitable elements in these groups are very close to silicon on the periodic table and thus have very similar properties. The P and N conductive layers are very important, and the most important part of the chip is the transistors that are built on the P and N conductive layers. The wafer transistors are the smallest control units in microchips. Their job is to control electric voltages and currents. They are by far the most important components of electronic circuits, as every transistor on a chip contains P and N conductive layers. These layers are made of silicon crystals, and they also have an additional layer of silicon oxide which acts as an insulator. A layer of electrically conductive polysilicon is coated on top of this. How are microchips made? Step 1. Layout and design. Microchips have to always be carefully designed, as these are highly complex chips that are made up of billions of integrated and connected transistors that make up complex circuits such as microcontrollers and crypto chips. A few square millimeters have to be measured in size and carefully outlined. The actual number of microcomponents requires an in-depth design process that defines the chip's functions. This actually characterizes the chip's technical and physical properties. In fact, special design tools are used to draw up the plans for integrated circuits and construct a 3-dimensional architecture of sandwich layers. This blueprint is transferred to photomasks to give the geometric images of the circuits. The photomasks are used as image templates during the subsequent chip fabrication process to make sure that the microscopic structures of a chip are reproduced perfectly. These are the patterns that you'd be seeing on the microchip. They have to be made in a dust-free environment with stable temperature and humidity levels. Step 2. Putting it together in a clean room. The chips have to be made in a clean room where no more than one particle of dust larger than 0.5 micrometers is allowed in around 10 liters of air. This place is extremely sophisticated, with several million cubic meters of air being circulated every hour and hundreds of air volume regulators maintaining a constant airflow. The employees in these production areas have an extremely strict dress code. It is here that all the airlock chips are built on a base wafer that is cut from a silicon ingot depending on their size. Several dozen or several thousand chips can be made on one wafer because of their small size. The surface of the wafer is oxidized in a high-temperature furnace at approximately 1000 degrees Celsius to create a non-conductive layer. After this, a photoresist material is uniformly distributed on this non-conductive layer. Then, centrifugal force is used on this coating and the process creates a light-sensitive layer. The wafer is then exposed to light through the photomask in special exposure machines called steppers. Here, coaster-sized areas of the chip are used to transfer the complex geometric patterns of the circuit design to the silicon wafer. The exposed area of the chip pattern is developed, revealing the layer of oxide below. The unexposed part remains as it protects the layer of oxide. After this, the exposed layer of oxide is etched off in the areas that have been developed with plasma etching. In this process, special gases bond with the substrate to be removed in the reaction chamber. This enables the microscopic layers to be removed in the windows that were exposed and developed in the previous step. Once the photoresist residue has been stripped and after the wafer has been cleaned, it undergoes further oxidation. The polysilicon is then deposited on this insulation layer, and then the photoresist is applied once again and the wafer is exposed to light through the mask. The exposed photoresist is stripped again, and now the polysilicon and the thin oxide layer is etched off these two layers. Step 3. Doping process. This is the process where impure atoms are introduced into the exposed silicon and the ion implanter is used to include impurity-inducing atoms into the silicon. This changes the conductivity of the exposed silicon by mere fractions of a micrometer. After the photoresisting residue has been stripped, another oxide layer is applied and the wafer undergoes another cycle of applying photoresist exposure through the mask. The stripping contact holes are etched to allow the conductive layers, enabling the contacts and interconnections to be integrated into the wafer. This is done by depositing various metal alloys onto the wafer in the specialized machines. This increases the efficiency of the microchips. Step 4. Smooth finishing. The photoresist and the masks are applied such that the unexposed strips remain as is after the etching process. This provides a point of contact to the underlying layers to give the insulation layer a smooth finish. This requires a chemical-mechanical process which is used to polish away excess material with micrometer accuracy. These individual steps may be done many times in the fabrication process until the integrated circuit is finally complete. Depending on the size and type of the chip, the wafer will now have several dozen to thousands of chips. The individual chips are usually sought out of the wafer and the chips are not lined up flush with each other on the wafer. This is because the tiny parts of the wafer splinter off during the sawing process. Hence, a certain amount of space known as the scribe line is always kept between the individual chips. There are structures also put in this scribe line to take the measurements immediately after production. This is to just find out if the chips are of sound quality. These specific structures are destroyed later during the sawing process, and the size of the resulting chips typically varies between 1 square millimeter and a few square centimeters. Step 5. Assembly. The assembly is the stage where individual chips are placed in a package and the terminals are connected. The result is a finished semiconductor device that can be mounted on circuit boards employing the various types of terminals over many connections. There also would be ready-made semiconductor components in larger packages that are used for power-related activities. The semiconductors are made for many applications such as trains, electric cars, solar panels, and wind turbines. These semiconductors are constructed to convert electrical currents of up to several hundred amps and voltages that go way into the thousands. The switching at this level leads to very high temperatures, and this heat has to be dissipated through some cooling areas that are integrated into the packages. This is also an important aspect of semiconductors and has to be included during the manufacturing process. Quality checks for any device are extremely important. To check for the quality of such semiconductors, scanning electron microscopes are often used to repeatedly check the chips at different points in the production process. If we compare today's microelectronics with the breadth of human hair, we can see just how small these devices are, so the production process for this has to be highly specialized and perfect. Do you know anything more about how microchips are made? Have you ever seen a microchip? If so, where did you see it? Do you know more about its applications? Let us know in the comment section down below.
You're welcome back. In the studio with me is Engineer Issa Odebowale, the Deputy Chairman of the Nigerian Institute of Electrical and Electronic Engineers. You are welcome, sir.
Thank you, guys.
Last week, you remember that we discussed issue on the causes of electrical fire outbreak at home and in offices. My guest,
Yes.
what are the things that determines the use of normal cable? You know, we talked about using of substandard cable is a cause of fire outbreak. Now,
one of the causes.
Yeah, one of the causes of fire outbreak. Now, how do we now determine the use of the type of cable or the size of cable to use?
Yeah, thank you very much. This is the most difficult area in electrical installations that have to be handled by professionals who knows the onion issue. Because it's not a thing you can just say, hey, this is a cable, and identify it. There are processes we have to follow before you can identify it. Whether the first thing is to identify whether you are even using the right size. That's another thing. The right size of the cable for a particular area in the installation. Whether it's 1 mm, it's 1.5, 2.5, to be determined. It's to be determined by qualified registered engineer. Another thing is to know whether the cable you are using is even the standard one. Whether the cable you use, you call 2.5 is even 2.5. That's another assignment to be determined by electrical engineer, which another layman on the street might not know. Even after being designed by an electrical engineer that use 2.5 mm cable to use 1.5 or 4 mm. Even after it might have been designed, even when we go to the market, even to be able to, because we have, you know, with the common problem we have in Nigeria, we could talk of our market are flooded with substandard materials.
Yes.
Or even not even just fake materials. They will call 1 mm, 2.5, they will call this and that. That's another area where you need the service of electrical engineer to be able to determine the actual size of the cable you need. An average man doesn't know. If I call you this one 2.5, you don't know. An average man will not know. If you this is a 2.5. If you go to the market there, they will tell you this is 70 mm standard. This is 70 mm this standard, high standard, low standard. What define that? That is what we are called. That is one particular areas which need to be addressed properly by the engineers in this country. Otherwise, the future will be worse.
Okay. Sir, now you talked about contacting engineers in installation.
Yes, I did.
But I think we find it difficult in identifying electrical engineers. For example, if I want to build I'm building a house and I need to do electrical installation, how do I find an electrical engineer? Because it's easier to find the people that do electrical installation out there. They have shop all over.
All over. Yeah.
So it's easier to contact them.
Yeah.
So how do I get an electrical engineer? Where will I find them?
Thank you very much. That is area we are going. We have more than enough electrical engineers being ordered to utilized in this country. Because they are not, they have not been considered that they are necessary. Because in electrical, as well in electrical engineering, it's very easy to join two work together and get light. You can get light today, tomorrow, and that is okay for you. But if you want to get electrical engineers, you have more than electrical engineers around. Okay. Like Nigeria Institute of Electrical, that's one of the things we are doing now. Nigeria Institute of Electrical Engineers, that's why we are going more chartered. We are going chartered now.
Okay, don't go there yet. We are coming to that.
See, if you're an electrical engineer, you say you want to do a job, they can, with all due respect, engineering respect all cadres of engineering. Starting from the craftsman, technician, technology, and engineers. But everybody's job has to be well defined. That is the area.
Right,
so if you don't, please, it might be a little bit expensive initially. Initial cost will be a little bit expensive if you contact an engineer.
Yes,
but you are going to get the benefit. The running cost will be far lower than what is
okay, let me take you up on what you just said now.
Yes, sir.
We have cadres in engineering profession.
Yeah.
We have the engineers, technologists, technicians, and the craftsmen.
Yes.
Please let our people out there understand the role of each cadre of engineering.
You see, let me just start from the peak.
Okay.
The engineers you are talking about now, they are the supervisors of all other cadres.
Okay.
They design and supervise and monitor and determine what I'm going to be used.
Okay.
We have technologies. That is the next level there. Who can handle the job properly. That is handling of job, the installation and other things like that. The technician and the craftsmen, they assist them in getting this job done. Okay. So it is now the duty of engineer to to satisfy to plan the job, design the job, and satisfy the okay.
Okay.
Yeah, that is.
All right, thank you. Now let's now go to our focus today, which is the role of engineering professional bodies in engineering practices.
Okay.
Koren, NSC, NATE. What are these bodies, and are they not duplication of efforts?
No. Thank you very much. They are not duplication of effort. Korea, we call it Korea, that's the Council for the Regulation of Engineering and Nigerians, established by the federal government.
Okay.
To set the standard, to become a member of any cadres you've already mentioned earlier.
Okay.
So this is the minimum qualification for you to be an engineer, this and that.
Okay.
Then, the Nigerian, let me take, like an example, let me take Nigerian Institute of Engineers, Nigerian Institute of Electrical Engineers, let me take them for example. Okay. These are the association of the professional bodies.
Okay.
Their duty is to maintain, improve on the capabilities, ethics, and education of the professionals in that cadre.
Okay.
And to maintain that the ethics are maintained.
Okay. Yeah. All right. What about NATE?
NATE is for the technologies.
Okay.
Like
the NSC
technology engineers. NSC is for the Nigerian engineers. NIE is for electrical engineers. NATE is for technologies.
Okay. Yeah. Now, recently we learned that NIEEE, Nigerian Institute of Electrical and Electronic Engineers, are trying to go shattered.
Yes, sir.
And why are they doing this? What is the implication on the practices of electrical and electronic engineering?
You see, thank you very much. I really welcome that question.
Okay.
Electrical engineering is one of the aspects of engineering that is very, very wide. Consequently, it's been massively abused. Talk of, electrical engineering can be, when we talk of generation, transmission, construction, this and that, even computer repairs, and some other ones like that. We now discover that our people are not getting the value for their money.
Okay.
The community are not getting value for their money because it has been prohibited. It has been so abused that everybody can do this, everybody can do that. And there has been a lot of complaints on that. But for us to be able to research the job of an engineer, who will be held responsible, who I know, because the ego is there for the engineer. You want to protect them. It's better you remain poor. You understand?
Yeah.
Than to be crucified in your profession. So we want to hammer the nail on the board. We want to lay emphasis on that professionalism. There are no professionalism again. Everybody just go to anywhere. Like those I've told you. Go to any place, you see socket here. Even, let me quickly comment. Go to some houses. Somebody was asking me that use of extension tables. In private houses, it's not well encouraged to be using extension cables.
Why?
If you have we have so many types of these extension cables, substandard extension cables, yes. And that is one of the major sources of electrical fire. So it's better you make provision for your socket, stand at appropriate position, whereby you think they are needed. I need this thing here, I need that thing here, I need this thing here. Put it there. It may be twins or three or something like that socket here, so that you can use your socket. I want to use fan, I want to use television, I want to use fridge. You put them on what side of extension wire. So in domestic houses, whereby you can be on and off, it is not highly accurate to be using extension cables most often. It's not encouraging. So, as professionals, we want to really let the government, the engineers get value for their knowledge, and we want the community at large to benefit from the pool of engineers, electrical engineers we have.
Is NSC not doing this?
NSC has become a very big family. It's a very, very big family.
Okay.
Because, and you know, it might not be very easy because they have a lot to do. If I start mentioning the type of divisions you have in NSC today, about 16. Even under that 16, even electrical alone, we have power, we have machine, we have control, we have communication, this and that, and we have to be monitored. For proper monitoring and to ascertain that these people are well supervised and the people get return for their money, that's why we need to be certified. So that not only that, we want the law to back it up. To back this job, we want law to back it up that you can only do this if you want to do this, because people always take advantage. Where there is no law, there are no sin.
Yes.
You can do whatever you have. But if there's a law, back it up by so thing. People will be able to understand. Yeah, I don't know electrical engineer because you don't need them. If you need electrical engineer today, we have more than enough. Okay. And they're being underutilized. And it's even your house. If you use an electrical engineer, it's like a maintenance installation. Domestic house installation is like a maintenance-free installation. You don't need to become no, because bad job has been done there already.
Okay. You talked about the advantage of this charter to the people. How about the engineers themselves? How is it going to affect their practices?
Yeah.
And in what way is it going to have make impacts in their life?
They are going to be more involved now. They'll be involved better. Even because you are not chartered, things are going bad. You cannot even complain because there is no law guiding it.
Okay.
But now, if there is a law guiding it that you have to stop this, stop that, this, and that, you feel proud of being an engineer. Not any roadside mechanic can be competing with you. You'll be able to deliver what you have.
And because of our time,
Yeah.
you talked about the substandard materials in markets.
Yes, sir.
How do you get into a market? Because if they are not in the market, we will not use them for installation.
Yeah.
What is NIEEE or NSC or Koren is doing in ensuring that these substandard materials are not in the market?
Okay. I think you know there's a body for that already. The Standard Regulation of Nigeria. And thank God, I have to debt return this level for some time. Just like another product you have in the market here, I think they've been trying. But if NIEEE now becomes chartered, that's a part of the job we are going to share with them. To assist them, not because Standard Regulation is, we have electrical engineers there already. But as a community people, that's why we're going to help them to make sure that these materials are not available. Because most of the thing that happens is because of this bad socket, bad cable, bad this, bad that. That's why. Even I think at some area where we have farm, you can even use your hand to foot the blade.
All right, my guest.
Yes, sir.
Now, to round it up, let's go back because our viewers need to understand the best practices. If I want to build a house and I need to do electrical installation or an existing house,
You want to do it.
what is the best way to go about this process?
The best way and the cheapest way. This should be considered to be, maybe you may consider as a consultant, a qualified and registered electrical engineer.
Okay, sir. We appreciate you for being on the program.
Thank you very much.
And we believe that viewers out there understand more of the role of NIEEE, Nigeria Society of Engineers, and Koren itself in ensuring standard practice in engineering profession. We appreciate you.
Thank you very much.
My guest has been Engineer Yisao Odebowale, the Deputy Chairman of Nigeria Institute of Electrical and Electronic Engineers in Oshobo. Thank you so much for coming.
You're welcome.
We hope that when we invite you next time, you